Yeah, thank you very much. So, even though I have 8 years experience of data acquisition, I want to say that there's experience and there's like relevant experience. I will explain later why I think the relevant experience is 4 years now, because the things changed. Yeah, as you can already, I think everyone saw the graph. From 2010 till up now, the data exploded. Uh, on the internet right now it's 181 zettabytes of data. I don't know what the number. If you ask me to write it, I don't know what the number is. And daily, there's over 2 or 400 million of terabytes of data produced. And the scale is not the issue. The issue is that this data is not structured. It's complicated. In 2000s, you can do the screenshot of the whole internet on your computer. Right now, you have 3D videos. You have some specific AI data that you need to train the model. You have neurons. You have everything that is not the text anymore. It's not the image anymore. It's complicated, and to understand it, you also need to do something with it, so you can read it and actually get some insights from the data. So, yeah, that's the issue. Is not that data is exploding. The issue that it's exploding in the way that we need to structure it. So it's unstructured explode. Yeah. So the next one. So when you get the data, you work with the data. Every company works with the data, even though if you're in finance, even if you're, I don't know, in the pharmaceuticals, you work with the data, you need to get it, you need to understand it. And when you get the data, it's not about how many data you have, it's about what conclusions you can get from the data. So, and not all companies can have this transition from gathering and storing the data to the actual insights and acting on the data. That's the problem, because 97% of the business right now invests in the big data, but not many succeeds. There's some reasons for that. First of all, let's say, not everyone knows on what they should look. Not everyone knows, or not everyone can react fast. So that's the problem. That's when AI can help us, because for the person or for the team, it's hard to get to check the raw data, even if they can mutate it. For the AI, when you can pull the context, you will have some results. Not always good results, but still results. So there's three main ways you can get the data, the public data, through the API connections, through the actual feed that was provided to you, or get it from the web. And let's be honest, the interesting data that we're actually interested in usually not provided to us. It's usually you need to get it, you need to avoid some blockings, because not everyone wants to see to learn on it. So yeah, that's where our Python trio is come to help. So the Scrapy, the Playwright, the Selenium, I assume everyone worked with them already here. So let's focus on how we can combine them and why we don't need them. So 1 second. So the Scrapy is what you reach when you need to crawl at the scale. It's already included that it can be auto-throttled, and it can be in a there's Scrapy Splash. It can be how you call it, unnoticed way. You can get to the data. The problem with the Scrapy, it's struggles with the JavaScript. It's not load the page. That's why we use the Playwright. Before that, we used the Selenium, but Selenium has its special cipher suite that it's not actually work anymore that well. The Playwright works well here. It works much faster. The problem with the Playwright, it's relatively new, and it's doesn't have the legacy of the Selenium that was built before. So that's why sometimes we combine. Sometimes Selenium works better on the one website. Sometimes Playwright works better on the other websites. About the bot protection systems and TLS fingerprinting. So that's why I told that I think 4 years is the relevant experience because before 2017 there was kind of easy thing that you can do. You can change your IP address and you're a new user. You can change your headers. You can change your cookie session and you're a new user. In the 2017, there was presented GA3 fingerprint. So what is doing? It's basically take a snapshot of your TLS, of your headers, of your everything of your system, and even though you change the IP address, but now you're the same user for the server. So that was the issue, and the problem was that you also can't spoof them easily because you need to be a real user to get this GA3 fingerprint. But time goes on, and we fight it. The problem with that, when you use this GA3 cookie, GA3 fingerprint, sorry, you actually can ban the actual user, because when you use the GA3, it means that somewhere in the world, some person have the same the GA3 fingerprint. So companies that figured it out, they decided, well, we need to not only just block by the fingerprint, we need to block it and check the behavior of the user. That's why from 2022, they introduced the GA4. It's more structured GA3, basically, but also it looks on how recently you go to the website, what actions did you did, and so on and so forth. There's also ways to avoid that, and here is the what happens is that we're safe now, because in terms of the blocking, the website can block everyone, every bot, because they will also block the actual users. And usually, when traffic goes this low, you're losing the revenue. So that's why sometimes you can go through, and as soon as you went through, you can take a snapshot of this GA4 and be not so rough, but still get the automation to extract the data. Yeah. So maybe also I want to mention that there's the companies that have their own blocking system, like Cloudflare, Akamai, Perimetrix. I think you're aware of them if you ever faced with the blocks. You definitely get one of them. They also the big companies, and it's hard for if you're a small team, it's hard to compete with them because they spend millions and they earn millions on helping to block you. So here where we can equalize. We can equalize when we use AI. So on their hand, they these behavior patterns they learn about, they put it through the AI, and AI helps them to say, okay, this is suspicious behavior. This is not the person. This is actually bot. So what we do before, we just
tune our fingerprint a little bit, tune our headers, tune our cookies, change the IP address, and we are totally new, totally fresh. And right now, basically, what we can do on all our tries before, we can train the data, or we can train the model, and in case this happens, you can reduce the cost of the working hours of the team, because you can fight AI versus AI, basically, this way. Yeah, well, I wasn't expecting someone to laugh about this, okay? Because it's a serious thing. Soon we will fight it. So, what is happened after we get the data? The important thing that our data, we need to basically understand it, and we don't want to read it all alone by ourselves. We want to use the automation here. And if you just get the HTML and put it to the model, you will spend a huge amount of tokens first, because there's a lot of noise, like tags, HTML tags. You don't need them. So first of all, what you need to do is you need to clean the data. You need to remove all that doesn't make sense and not actually what you need. That's the first step, and the second step, that reduces the actually amount of tokens and the price for that. And also, there's no sense of doing that if you're not deduplicate your data. So if there's a lot of duplicates, you'll spend again a lot of tokens on things that you don't want. But again, if you're just trying to deduplicate what you have, for example, if I have, I don't know, the chair and the armchair, so it's similar. It's similar, but it's different in the raw deduplication. So this the vector and embedding helps us. So basically, what vector embedding do is it creates the coordinates. Let's imagine them like this, and if this word matches around the circle to another word, they are the same words, and we deduplicate them. So like cat and the kitten will be deduplicated. That's how you can reduce the cost of processing the data. What else? What next do you do with the clean data already? Then you store it, enrich and classify your data, analyze. You can, after you enrich and classify it, you can analyze it in the model, in the statistic model, in the AI model. It doesn't actually matter. And the most important part that, when you get the actual insights, you need to act on the data, whether it be buying some stocks or whether it be, I don't know, alerts on your dashboard that something happens. And you need to focus on something on your pipeline or on your product. So the most important thing is act. So if you don't act, you don't need to do everything before, obviously. And I would like to show you 3 case studies that show the different ways we can use the data, and they are the same in the terms of pipelines, that if you think about it. So the first case study is the F1. It's Formula 1. Someone knows what is that? Everyone, yeah? They are racing the circles. Okay. So in 2025, the McLaren team was very successful because they had a great car. But also that what we noticed that they were improving on the practices. So with each practice, they have terabyte of data. Not the terabyte, a little bit less, but a lot of data. And when you qualify, you have limited amount of time. You need to know what to tune so you can improve your next lap. With that, they analyze all the data they collect from the sensors, from the tire pressure, from the cornering, from everything, and they tune the settings of the car so they can improve with each stop they make. And basically, you can download, or you can take a photo of this one, or just open it. It's the GitHub repository when you can get all the data from 2025 for every driver, and you can try to analyze it yourself. Basically, what's happening here, they are doing this in real time, and otherwise they will not be able to proceed on that. Otherwise, they will need to have a day to break and then continue. But with the different tracks, they have different settings. So that's where they use the AI to improve their competitiveness. Yeah, it's not a great, like the chart, because when I made it, it was a little bit better, but it shows then from practice to practice, they decrease the lap time. Yeah, but not for much, but still it was improvement. And this works only on, not on the race, this works only on the practice or on the qualification. It works when you have clean circle, right? When you don't have competitors, because they can stop you and you can't rely only on the data. But when you have clean lab, relying on the data helps them to improve. And yeah, that was basically the graph that shows that it was the Grand Prix Australia when the McLaren member, who was that? Lando Norris wants that one, I think. Yeah. Second case study I want to talk about, that was kind of what we are doing right now in our company. That it is a sentiment analysis of the marketing advertisement for the product. So imagine yourself, the big company that wants to advertise not only product, but also the brand, and the brand appearance is matter for them. So they launch the advertisement company, but before they launch the advertisement company, they have focus groups, they have the response they need, but they don't have the response from the result. They can see it in sales, but sales comes not so quick. And if your marketing campaign is ongoing, you can't quick change it. So for that purposes, we created the sentiment analysis that analyzes Twitter, now X, that also analyzes Reddit, and what users says and mentions about the brand, about this campaign. Of course, the users, that verified users, they have additional weights because their word spread more. So it means that they are, if they're negative, they're like lead the group of people to be also negative. And then it means you need to change something. Or if it was your intention, because negative advertisement is also advertisement, and sometimes it works even better. If it was your intention, that also you will get this info. Also, it can be working on if it's about not the product, but about the brand. You can also then make the statements about how the stock's gonna go, because the people buy the stocks. It's not always true. Don't put all your money on the stocks only because someone told you so. But yeah, that's one of the parameters that can work. And actually, this one is highly used in the big brands. We have the example is the Samsung, Nike, and HP. the notebooks. Before that was also NVIDIA, but now they're not our client anymore. Yes, so it helps you to track the real time, as I mentioned before, and to make changes if something goes wrong, and or stop the campaign because it's also consuming some money if you see that it's not the result that you expected. And the third case study, basically what happens here is the NASA and the European Space Agency, they have vast amount of data of the shootings from the telescopes of the stars. It's not the shooting itself, it's the series of shootings that matters, because then you can see the movements of the stars, the movements of the exoplanets, and when the planet, how you see the planet, when it comes across the star, you don't see the light from the star, means there's the planet. They analyze this data to explore new objects in the universe. And the last year, in 2025, there was a person that just grabbed some data that they produced. It's open source data. And he discovered 7 planets all by himself. Of course, he was using AI. But so it shows that it can be anyone. It's not so hard to do, actually. I mean, not to get the planet. I mean, to start with this one and to be interested in the planets and in the stars. But this one shows that, I mean, how it's related to the get the data. It's not related to the get the data. It shows that the pipeline that you built can be working on the commercial data, can be work on aerospace data, can be work on any data. So the logic that you implement, that you analyze and you act on your data stays the same. Yeah, I think that's all I wanted to say for today. Thank you.